Alright, so we're doing exercise 9G, which is all about independent probability, and we're looking at question 1 in this video. Before we delve into the question itself, let's remind ourselves what independent probability is. So let me just read this short little quotation. In probability, we say two events are independent if knowing one event occurred doesn't change the probability of the other event. So this is in direct contrast to what we learned in our last exercise about conditional probability. In terms of conditional probability, if we know one event occurred, that is going to change the probability of the other event. So now, knowing this about independent and conditional probability, let's now launch into the question, which reads, 100 people were questioned and classified according to sex and whether or not they think private individuals should be allowed to carry guns. The results are shown in the table. So here's our table. It's broken down in terms of sex, male and female, and in terms of their opinion, yes or no. And here is the question that is posed to us. Is support for private individuals carrying guns independent of sex? Let me read it again. Is support for private individuals carrying guns independent of sex? If I was to say this in another way, what it's asking is, if we know an individual's sex, is that going to impact the probability of them saying yes or no? So let's now explore this, and let's explore it by first considering what we know about conditional probability. So here is a statement concerning conditional probability. So the probability of an individual saying yes, given they are male, is going to be equal to the probability of yes intersection of male divided by the probability of male. This formula right here is what we learned in the last exercise. So if you're having any trouble with it, please refer back to that. So now, knowing this about conditional probability, let's think about independent probability. So independent probability tells me that the occurrence of one event, for instance them being male, is going to have no effect on the probability of the occurrence of the other event. So in this case, them saying yes. So if I was to write that down mathematically, what I could say is the probability of them saying yes, given they are male, is going to be equal to the probability of them saying yes. So that means that the sex of the individual is going to have no impact on them saying yes or no. So the probability of them saying yes if they are a male is just going to be the probability of them saying yes, because sex has nothing to do with it. Let's now go on to our next statement if this is true. So as you can see here, I have, knowing that this and this are the same, I have put this into this spot. So all this statement is me replacing this with this. So now I could say, knowing that the events are independent, so here I'm just assuming they are independent, what we could say is that the probability of yes is going to be equal to the probability of yes intersection of male divided by the probability of them being male. Now, the next thing that I'm going to do is some rearranging. So I'm going to times both sides by the probability of male times the probability of male. And having done that, this and this is going to go away, which means I'm now going to get this statement. The probability of them saying yes times the probability of them being male is going to be equal to the probability of yes intersection with male. So if my events are independent, so if someone's support for carrying guns is independent of sex, this statement right here should be true. So now, we haven't even answered the question yet. This is all just background information. We're going to determine whether this statement is true, and that's going to give us the answer to our question. So what we're going to do is, and I'm going to take this, and I'm going to answer it. So what is the probability of an individual saying yes? What is the probability of an individual saying yes? Well, 65 people said yes. And we can divide that out of 100 because 100 people were asked. Now we're going to times that by the probability of people that were male. So we know that 60 people were male, and that's out of 100 people. So 60 out of 100. And therefore our answer to this is going to be 65 times 60. 65 over 100 times 60 over 100 is going to be 39 over 100. So there's our answer to the first part. We now need to figure out the probability of yes intersection with male. So now we have to figure out this part. So let me copy it, bring that over here. How are we going to figure this out? Well, this is a bit easier for us to figure out. The intersection of yes and male. So here's yes, here's male, here's our intersection point. So it's going to be 35 over 100 because we're still dealing with that. So there are our answers, 39 over 100 and 35 out of 100. Now, if these events are independent, these two things should have been equal to one another. But hopefully you all know that if I was to write these as decimals, 0.35 is not equal to 0.39. They're not equal to each other. So my very last statement is going to be therefore not independent. Oops, if I can spell. Independent. Lucky this is maths and not English class. There we go. So what we did here is I've shown you how we get a formula which is going to tell me or not events are independent or not. I then did some calculations and determined that these are not equal to each other and therefore they're not independent. Hopefully this video was helpful to you in answering question 1.